Hi guys, it's Mark here. Um, I'm here to talk about things to do to be successful in Algebra 2. First thing to be successful in Algebra 2 is pay attention in class. Sounds simple, sounds obvious, and it is. Um, in class, don't be playing on your phone or talking to your buddies. Pay attention and learn the material. It won't take long if you focus on it, and then you'll have it down, and you won't have to worry about having to figure it out last minute right before the test. Just pay attention, you'll get it easy. Um, Second thing is do homework. Your teacher may or may not require you to do homework. She might not check it, and so you might get lazy and be like, "Well, I don't really have to do it, do I?" It's important to do it because you'll have a better grasp on it. Even just doing a few problems a night will help because uh, you'll take what you learn in class and then you'll bring it home and do it over and over again. That repetition is gonna help your memory, so you don't show up in class the next day like, what did we do? So that's one thing. Third thing, use your resources. Teachers might have like Edmodo, Remind 101, a textbook, websites that you can go to, Khan Academy, stuff like that, apps maybe. Use those to your advantage. In our technology filled world, there's a lot of resources that you can use, and you should definitely use those. Those will help you a lot. Um, Fourth thing is don't be afraid to go to tutoring. A lot of people think, oh, I don't need to go to tutoring. I'm not stupid, or I don't really need help. But I mean, one-on-one time with your teacher is a great thing. It can help you so much, and I just encourage y'all to do that. And the fifth and final thing is to not be afraid to ask questions. If you don't understand something in class, ask the teacher. They'll be happy to help you. They want you to figure it out, and so just, I don't know, ask questions if you don't understand, the concept, and it'll help you to figure it out. Okay, so a few things from each quarter that I did well with and I struggled with. For quarter one, graphing equations given points and slope. So this I thought was really easy because it's just kind of obvious. So if it goes through 0, 4, which is 0, 1, 2, 3, 4, and then the slope is 2, that means it's going to go up 2 over 1, up 2 over 1, so it'll be a line like that. And then go back, it'll be over 1, down 2, over 1, down 2. So, I don't know, for me that just seemed kind of obvious. It's pretty simple. Something that was difficult would be square root functions. These I thought were hard because we'd never done square root functions before, and it was just something new to me. Of course, it's not that so hard once you think about it. Square root of 25 is 5, so it's just 5x. And then square root of 100 is 10 plus 10. So it's not really that difficult once you kind of get into it. Quarter two, one thing I thought was easy was transformations, quadratic. Transformations have always been easy. It's something we've been doing for a while, so I thought it was pretty easy. For example, like if it was a reflection across the x-axis, it looks something like this. If it was a reflection across the y-axis, it would look something like that. If it was a translation over here, maybe something like that. I don't know, that I thought was pretty simple. Factoring was one thing that I thought was pretty difficult, but eventually I got it. It was difficult because you don't see everything in here. See, to get this, it's not just x plus 4 or whatever like you'd think, because there's more to it. This would actually be x plus 4 times x minus 4. And whenever you FOIL that, it ends up being x squared plus 4x minus 4x minus 16. And the plus 4x and minus 4x cancel out. So you're stuck with just the x squared minus 16, which is pretty confusing. Alright, quarter three, one thing I thought was easy was direct and inverse variation. Pretty straightforward. When x goes up for direct, y goes up 2. So when x is 5, y is 2. When x is 10, y is 4. When x is 15, y is 6. When x is 20, y is 8. Makes sense. And then for for inverse variation, it's the exact opposite. When x goes up or down, y does the opposite. So when x goes down, y goes up. So 20, it's 20, they're the same. And then whenever it goes up to 30, it goes down to 10. And whenever x is 40, it goes to 0. Whenever x is 50, it goes to negative 10. So they're just going in opposite directions. One thing I thought was hard from quarter 3 is rational exponents. Thought it was difficult because, again, we'd never done this before. It was something new to me. I didn't really understand it. But after a while, I caught on, and it's pretty simple. It's just, like, if it's 1/2, it's really just squaring it. So it's basically the same thing as writing that. It was the same thing. Square root of 4 is 2, and 4 to the 1/2 power is also 2. They're the same. All right, for quarter 4, one thing that I thought was easy was synthetic division. All right, so for example, this you just do, you bring down the 1, -5 times 1, -5, 7 and -5 is 2, -5 and 2 is -10, 10 and -10 is 0, so it's just going to be x plus 2, which is really easy in my opinion. But what I thought was hard was long division, which is essentially the same thing, it's just a different route to do it. And I thought this was difficult because it takes more work and we'd never done it before again. So what you want to do is you want to get this number to be that. So well, that'd be 2x. 2x gets you 4x squared. 2x times 3 is 6x. And then you do negative and negative. So that would be, that cancels out, and then it'd be negative 6x. And then we'll get you, or then you bring down negative 9. Alright, so you want to get negative 6x. And so that would be 2, or that'd be negative 2x. So actually, that'd be negative 3. Negative 3 times 2x is negative 6x, then negative 3. Positive 3 is negative 9. Of course, you inverse that, and then that all cancels out, 0, so and you get just 2x minus 3. So it's not that hard, it's just a longer process of getting there. Alright, and then one thing that you can utilize in the real world that I thought was cool is probably quadratic functions. I thought quadratics were really cool because they, like one example was a rocket ship or a missile, you know, and I think that's a pretty cool like real world example because, you know, they go up and then they come back down, kind of like a quadratic expression, and you can graph what a missile or a rocket ship or something is going to do from that. And I thought that was really interesting because it was a way I could see a graph mathematically have like a purpose in the real world. So yeah, I thought that was pretty interesting.